The equation of a curve in polar coordinates is r is equal to ln 1 plus sine theta for theta between alpha and beta, where alpha and beta are non-negative angles. The curve consists of a single closed loop through the pole. So the pole is like the origin, so it's probably going to look, I don't know, something like that. By solving the equation r is equal to 0, determine the smallest possible values for alpha and beta. So r is equal to ln 1 plus sine theta, and we're solving the equation r equals 0. So 0 is equal to ln 1 plus sine theta. Let's e that side. E to the 0 is 1, take away the 1, so you get sine theta equals 0. And sine theta is 0 at 0 and pi. So actually this diagram is not correct. It exists from 0 to pi, so it's probably something like that. Find, using your calculator, the area enclosed by the curve, giving your answer to 4 significant figures. So to find out the area, we're just going to do half integral between our limits, which were pi and 0, which we found in part A, of ln of r squared, isn't it? So r is ln 1 plus sine theta, and we're going to square that, and it's d theta. And it just says whack in the calculator, so make sure you just whack it in properly, and you should get 0.4162 to 4 significant figures. And then part C says, hence, by considering the value of r at theta equals alpha plus beta over 2, so show that the loop is not circular. Okay, so my diagram's wrong again. We have to show it's not circular. That looks like a circle. Let's just draw kind of something like that. So alpha plus beta over 2, that's going to be the halfway point over here. Okay, so let's work out the r value at alpha, the r value when theta is equal to alpha plus beta over 2. So r is equal to ln 1 plus sine theta, and theta is alpha plus beta over 2. So that's going to give us ln 1 plus sine of pi over 2. Sine of pi over 2 is 1, so that's just 1. So ln 2. And that's going to be, if you think about, if it was a circle, then that would be like the diameter of the circle. So now, if I work out the numerical value of that, we can see that the diameter is 0.6931, and that's the value of ln 2. So if it was a circle, what would the area of this circle be? Well, that would be pi r squared, so I've got to half the diameter and square it, and then times that by pi. And if I do that, I get 0.3773. But in part B, we worked out that the area of this shape was 0.4162. And because 0.3773, if we're assuming it is a circle, the area should have been 0.3773, but it's not equal to 0.4162, so therefore it's not a loop, not a circular loop.